So I'm going to go through chapter 12a.1, which is just some operations with surds. Okay, so let's have a look at 1a, which is the square root of 11 times the square root of 11. So when you have any two things that are being multiplied together that are square roots, if the square root part or the numbers in the square roots are the same, you can just write it as the same answer without the square root. Part B. When you multiply square roots, the cool thing is that you can multiply them out inside the square root. So this will become square root 15. Let's see. So what we have next is root 3 squared. Well, I'll just break this up a little bit, but the basic idea is that you can write this as square root 3 times the square root 3, which is very similar to the question from part A, which will become 3. Yeah, when you have two square root things being times together, the square roots can kind of cancel out. Okay, it's the easiest way of describing it. Okay. 1D, you're looking at square root 5 times square root 6. So once again, just like in B, you can square root everything inside. Cool. Wonderful. So this one's a bit different. 2 root 2 times root 2. So I'm going to do this a bit of a longer kind of convoluted way first, just so that it makes sense for later calculations. But the way I'm going to do this question is just by breaking this up by going 2 times square root 2 times square root 2. So I'm breaking up this part here into two components. And the reason I do that is because then I can times these two together. And remember, if you have two things that are times and they're square roots, and they're exactly the same, then that will become just 2. 2 times 2 is 4. Yeah, cool. And so on the side here, I've got a graphics calculator, and I'll just do this calculation as well. So 2 root 2, multiply that by root 2, comes out to be 4. Wonderful. Next, we got 3 root 2. Sorry for that interruption. So we got 3 root 2 times 2 root 2. So once again, I'm just going to break up each of these two components similarly how I did to question 1e, sorry. So I'm going to have 3 times root 2 times 2 times root 2. I'm going to times those two parts first. So I'm going to get 3 times 2 times 2. Yep, those two will make that. And then we'll have 3 times 2, which will make 6. 6 times 2 will make 12. And all of this can be verified on your calculator as well. So 3 root 2, multiply that by 2 root 2, comes out to be 12. So it's good that you have a calculator and you can do it in your calculator. It's also very good to make sure that you can do it by hand as well, because there are going to be situations where you may need to know how to do this by hand. Okay, 3 root 7 times 2 root 7. Once again, I'm just going to break this up. And then I'm going to just do, the 3 and the 2 together to make 6. And the square root 7 and the square root 7, well, they will make 7. 6 times 7 will make 42. Okay. So 3 root 5 squared. I'm just going to write it as 3 root 5 times 3 root 5. And if you're at the stage where you can kind of see where this is going, you're welcome to skip some steps, I'm guessing. So 3 and the 3 makes a 9. And the root 5 and the root 5 makes a 5. 9 times 5 is 45. All right. All right, 1h and then 1i. So we got, okay, so this one's a bit different. You got root 12 over root 2. Okay, cool. So this one's a bit trickier. All right, cool. They're asking here to write it as a rational number. Okay. So I'm just going to write this a little bit lower just so I get a little bit more space. So the way I'm going to do this is by breaking the top part, the square root 12 up into two individual components. So I'm going to break it up like this. Square root 12 is 2 times 6, like that. Okay. Well, then I can break up this 2 times 6 into individuals 2 times root 2 times root 6 over root 2. Okay. To which this and this will cancel off. So what you're left with is just root 6. Okay, so that should be your answer. And you're welcome to verify this on the calculator as well. Yeah, root 6. All right, let's keep going. So that's 1i, this is 1j. So you got root 18 over root 3. And we're just going to do a very similar technique. We're going to just break up this 18. 6 times 3, square root 3. And this 6 and this 3 will make a square root 6 times the square root 3 over square root 3. This will cancel with that. So you're just left with square root 6, just like you did before. Okay, let's keep going. 1k, you're looking at root 20 over root 5. So just like in the previous couple of questions, I'm just going to break them up into two individual components. So I'm going to break this up into square root 4 times root 5. Yep. Then this will cancel with this, so you're left with square root 4. It's really important just to make sure that you check your end answer. Don't leave it at square root 4 because square root 4 is just 2. So yeah, make sure that you're being accurate in your answer. Cool. Then we got 1L. So what do we have? We got root 6 times root 10 all over root 12. Okay, cool. So there's a few ways that we can do this. Let's just do it in parts. Okay. So this is the way I'm going to do it. I'm going to break up the square root 12 is square root 2 times square root 6, because the 2 and the 6 will make 12. And what we notice is that those two will cancel out. So you're left with square root 10 over square root 2. And then what I realize is that you can break up square root 10 as root 2 times root 5 over root 2. To which these will now cancel out. So you're left with just root 5. Okay. And so if you put that on your calculator, root 6 times root 10 over root 12, you come out to be root 5. Yeah, cool. All right, cool. So that's the first set of questions, question 1. I'll start moving on to the material from question 2. Okay, cool. So this question reads, write in the form a square root b, where a and b are integers, and a is large as possible. Okay, cool. So I'm looking at question 2a at the moment, and it's written as square root 8. And basically what they're trying to ask you to do is, if you put in square root 8 into your calculator, it'll come out as 2 square root 2. What they're asking you to do is, well, work out kind of how did they get to 2 square root 2 is basically the idea for these type of questions, for question 2 on page 319. Okay, cool. And the way you kind of do it is you break up the square root 8 into two kind of numbers. So you got like some number here times square root some number here. Yeah, so you want to break up the 8 into two numbers. Yeah. The key thing is that you want one of those numbers, at least one of those numbers, to be a square number. So it could be 4, or it could be, so it could be like 2 times 2 equals to 4, or 9, because 9 is 3 times 3, or it could be 16, because 4 times 4, or it could be 25, because it's 5 times 5. Basically, you want to just break it down so that one of those numbers is a square number, one of these kind of category numbers here. Okay, so this is a bit, maybe something like that might be a bit easier to look at. Okay, and so the way I'll do it now is the square root 8 can be written as square root 4 times square root 2. And note that 4 is a square number because it's like the first one in the list. Yeah. Square root 4 on like if you square root 4, it'll become 2. And hence you have 2 square root 2. Yeah. So that's basically what you're trying to accomplish with these questions. Now it might be worth actually writing down a list of the square numbers. Some people are really good at seeing the square numbers, and so they don't need to write it down. If you need to write it down, just have it as like a reference somewhere. All right, cool. Let's have a look at 2b. So you got root 12. So it's the same thing. You want to break it up into 2 separate parts with at least one of them being a square number. So in this case, I'm going to break it up as a 4 and a 3. Yeah, and the square root 4 is 2. So hence you get 2 root 3. Yeah, and if you chuck this on a calculator, you get 2 root 3. All right, cool. Let's just keep going. Square root 20. So I know that becomes square root 4 times square root 5. Yeah, and square root 4 will become 2 times root 5. So this will become 2 square root 5. Okay. So for all these questions that we're doing in question 2, we're just breaking it up so that one number is a square number. Okay, or depends on where you're from. Maybe you might have heard the term a perfect square. In either case, it's just a perfect square or a square number. 2D, root 32. So there's a few ways that we can break this down. I'll do it the most, I'll show both ways. So the first way you could do it is by doing this, 4 and an 8. Yeah, and this would give you good results because square root 4 will be 2 times square root 8. But in fact, you can actually break up the square root 8 even more. You can break it up as a square root 4 times a square root 2, which would make, yep. And so this will become 2 times 2 is 4. So that would make 4 root 2. So that's one way of doing it. And if you get your answer that way, that's fantastic. The alternative is instead of having square root 4 straight away, what you could do is go square root 16 times square root 2. This is also very, very good. It gets you to the answer a little bit faster because square root 16 is 4. Yeah, same answer. It's just that maybe some people need a few more steps, and that's okay. Whereas some other students can just see it straight away, that's okay as well. Okay, so either way is fine, as long as you get down to the correct answer. All right, cool. Let's just keep going. So once again, square root 27, you just want to break it up so that at least one of your numbers is a square root, square number. So I'm going to break this up as a 9 and a 3, because the square root of 9 is 3 times root 3, 3 root 3. Cool. 2f. So root 45. It takes a little bit of time to think about what numbers they break up into, and the more you do it, the more kind of experience you get. But in this case, I think it should be a 9 and a 5. Square root 9 should be 3, so that should become 3 root 5. Alright, cool. 2g, root 48. So, because I've been doing this for a good chunk of time, I'm pretty sure that I can break this up into square root 16 times square root 3. If you need to break it up into smaller factors, that's absolutely fine. Yeah, everyone runs their own race. Square root 16 is 4 times root 3, so it becomes 4 root 3. 2h square root 54 is equal to, okay, so let me just have a quick think. Yep, so it should be square root 9 times root 6, I think. Yep, so this will become 3 times root 6 to make 3 root 6. Cool. 2i root 50. Okay, so this one's a little bit more convenient. That's 25 times root 2. 5 times root 2, so that becomes 5 root 2. Alright, cool. So 2i, now we're looking at 2j. So you got root 80. Now, what's the biggest number? So I can't see the biggest number straight away, so I'm just going to break it up into a 4 and a 20. And this is definitely not necessarily the most efficient way of doing it, but it's just the easiest way for me. Okay. Now I'm gonna then break up the square root 20 into square root 4 times square root 5. 2 times 2 times root 5, which would make 2 times 2 makes 4. 4 times root 5 makes 4 root 5. All right, cool. What's next? 2k. So we got square root 96. Okay. Now I'm looking at this. Okay. Now I am pretty sure that this comes out to be square root 16 times square root 6. Yep. Square root 16 is 4. If you need to do it with a little bit more working out, you can break it up into square root 4. So square root 4 times square root 24. And then you can break up the square root 24 into a 4 and a 6 again. And the 2 and the 2 will make a 4. And then the 4 and the square root will make a 4 root 6. All right, cool. Okay, so that was 2k. Now we have 2l. So you got square root 108. Okay. Now, I know that this breaks up into 9 times square root 12. So square root 9 makes 3. Now, I can actually break up this 12 into a square root 4 and a square root 3. Okay. And this square root 4 will make 2. So you have 3 times 2 is 6 times root 3. So that makes 6 root 3. Alternatively, if you're able to see that square root 108 can be broken up into 36 and 3, that's good as well. When I was doing this question, it wasn't the first thing that came to my mind, but it's okay. Both answers get you, or both kind of methods get you to the same answer. Right, cool. All right, wonderful. I'm just going to go through the material in 12a.2 now. Okay. So I'll first write down the question. So this is the way that I kind of learned it, or learned this particular idea, where it says simplify. Whenever you have square roots, you can kind of treat them like the variables like x or y, or just any particular variable, okay? And you can kind of do the same kind of method that you did with variables to square roots as well. So 2x plus 3x makes 5x, okay? Or in this case, 5 square root 2, okay? Is the kind of idea. And likewise, if you had 2x plus 3y, you can't add these two together because they're not like terms, yeah? And so it's similarly, if you had square root 2 plus square root 3, you can't add these two together because square root 2 is not the same as square root 3. Yeah? So the idea for this entire section, or for question 1a, is you got to just see if the square root numbers are the same, because then they're considered like terms, and then you can kind of add them together similarly how you would do it with variables like x's or y's. Okay, cool. So I'll do part B, 1b, which is 2 square root 2 minus 3 root 2. And so because this square root parts are the same, they're considered to be like terms. And so the only thing you need to really consider is the 2 and the minus 3. So 2 minus 3 is minus 1. So you would have a minus 1 square root 2. Or you could just write it as minus root 2 is the way that you're supposed to do it. Cool. 1c. So you got 5 root 5 minus 3 root 5. And once again, because this part and this part are the same, you can just do the 5 and the minus 3. So the 5 and the minus 3 would become 2 square root 5. Cool. 1d. Yeah. Same idea. Because these two things are the same, you can just add up the 5 and the 3. So you get 8 root 5. Cool. All right, let's have a look at 1e. You got 3 root 5 minus 5 root 5. And once again, because the square root parts are the same, it's like they both have square root 5, all you have to worry about is the 3 minus the 5. So 3 minus 5 is minus 2, square root of 5. Okay, cool. Right. So you got, excuse me. So because you have square root 3's that are common in both terms, they're considered to be like terms. So you can just go 7 plus 2, which will make 9 root 3. So 9 root 6 minus 12 root 6. The same kind of idea. 9 minus 12 is minus 3 root 6. 1g, 1h. Root 2 plus root 2 plus root 2. So because these two are like terms, that would make 2 root 2. Yeah. And likewise, because these are like terms, they would add to make 3 root 2. All right, let's keep going with question 2. Okay, so you got root 2 in brackets 3 minus root 2. So this is a classic example of expanding brackets. So like the term on the outside multiplies by each of the terms on the inside. And so when you multiply root 2 by 3, you get 3 root 2. And when you multiply these two together, well, you would have a minus root 2 times root 2. So root 2 times root 2 makes 2. Yeah. And because these two terms here and here do not share the same square root value, they're not considered to be like terms. Hence, you can't add them together or subtract them from each other. Yeah. So square root of 5 times square root of 5, well, that will just make 5 plus 1 times square root of 5 is square root of 5. Cool. 2c. So you got root 10 bracket 3 plus 2 root 10. So once again, multiplying it out. So you get 3 root 10 plus, now I'll write this out a little bit. Yeah. And more importantly, I'll write this part out in its entirety. Yeah. So I broke up the 2 square root 10 as 2 times square root 10. And so what we have now is square root 10 times square root 10 to make 10. 2 times 10, oops, I should be writing equals everywhere. 20. All right, cool. All right. And then for 2d, root 7, 3 root 7 minus 4. So same thing, 3 times root 7 times root 7 minus, sorry, whoops. And then this will times that, minus 4 root 7. The 2 square root 7s will then multiply to make 7, 4 square root 7. 3 times 7 will make 21. Sorry, square root 7. Yeah, cool. All right. Let's keep going through question 2b. So these two will then multiply together, but don't forget the negative. So those kind of parts will become negative 5 root 3. Yep. The negative because that's a negative. The 5 because that's a 5. And a root 3 because that's a root 3. Cool. This will then multiply by that. So a negative and a positive will make a negative. And square root 3 times square root 3 will become 3. And so the answer will be negative 5 root 3 minus 3. All right, cool. And just the same thing. So that will become 2 times root 6 times root 6. And then this will make it negative 14 root 6. And so the root 6 times root 6 will become 6. 2 times 6 will make 12. Cool. Okay. Now let's look at 2g. Negative root 8. Root 8 minus 5. So the same kind of thing. This will become negative. So square root 8 times square root 8 will just be positive 8. Well, sorry, it will just be 8, sorry. And then 2 negatives will make a plus 5 root 8. 2h. And now we get the most trickiest one. So the way I kind of understood this when I first learned this was when two things are being times together, it's the not square root numbers times together and the square root parts times together. So the 3 and the 4, those will times because they're not square roots. So that becomes a minus 12 square root 2. And then these two parts will then multiply. And because like they're both negatives, this will be a plus. The numbers that are not in the square roots will then times together. So you got 3 and the 6 will make 18. And then the square roots times together, square root 2 times square root 2 will just make another 2 because square root 2 times square root 2 will just make 2. And so you got 18 times 2, which is 36. And so those are the questions from H. Sorry, those are the questions from question 2. Let's go to black. So this stuff here is very similar to stuff you may have done in a topic called quadratics, called the distributive law, where you do something like x times 3, 2 times x, and 2 times 3. Some of you might have also been told the acronym FOIL, and it's the same thing in this case, yeah? So the 5 and the 4 will make 20 because they'll times together. The 5 and the square root 2 will make 5 square root 2. The square root 2 and the 4 will make a 4 square root 2. And lastly, square root 2 and a square root 2 will make a positive 2. And so that's what they're asking when they say expand or simplify. Now what we have to do is just add the like terms together. So 20 plus 2 makes 22. And then 5 square root 2 and 4 square root 2, well, that'll make 9 square root 2. Cool. 3b. 7 plus 2 square root 3 multiplied by 4 plus root 3. Okay, so similar thing again. The 7 and the 4 will make 28. The 7 and the plus root 3 would become plus 7 root 3. The 2 square root 3 and the 4, the numbers on the outside of the square roots will times. So the 2 and the 4 will make 8 square root 3. And then lastly, 2 square root 3 times 3, well, that would be 2 times 3, because the square root 3's will times together to make 3. So you have 28 plus 7 root 3 plus 8 root 3 plus 6. And now we just got to kind of collect like terms. So 28 and a 6 makes 34, plus 7 and the 8 will make 15 root 3. So once again, 9 and the 4 make 36, plus 18 root 7, because the 2 and the 9 will make 18. This will make a minus 4 square root 7. And this one here will make a negative 2 times 7, because square root 7 times square root 7 will become 7. So 36 plus 18 minus 4 square root 7, that will become 14 root 7 minus 14, because 2 times 7 makes 14. 36 minus 14, that would make 22, plus 14 root 7. All right, cool. Then keeping up to speed, let's go up to 3D. The square root 3 times the 2, that'll make 2 square root 3. Those two will times together. So this will become negative, well, the square root 3 and the square root 3 will make 3. 3 and 3 is 9, so minus 9. 1 times 2 is 2, and 1 times that is just negative 3 square root 3. And then we just try our best to collect like terms. So 2 square root 3 minus 3 square root 3 will make negative root 3. Minus 9 plus 2 will make a minus 7. 3e, root 8 minus 6, 2 root 8 minus 3. So the square root 8 will make all times together to make 8, and then with the 2 we'll make 16. The negative 3 and the square root 8 will make negative 3 square root 8. The negative 6 and the 2 square root 8 will make a negative 12 root 8. And the negative 6 times by the negative 3 will make a positive 18. And then after that, we just collect a little bit of like terms. So this and this are like terms, and this are like terms. So 16 plus 18 makes 34. Hang on, is that correct? Yep. And negative 3 square root 8 minus 12 square root 8 would become negative 15 square root 8. And so this most likely is a very good answer. However, if you want to continue, you could break up the square root 18, it's the square root 8 as square root 2 times square root 4. And the square root 4 will become a 2. And so what you're left with is 34 minus 30 square root 2. Okay. And so if you have a Casio calculator, like I have on the side here, and you were to put this in, like this, it would give you the same answer that I got. It wouldn't give you this answer, even though that's the answer that seems most logical and easiest to get to. It's also important just to remember that you can break down your square roots in your surds. Cool. And let's finish off with question 3f, which is 2 root 5 minus 7 and 1 take 4 root 5. So cool. So anything times 1 is just whatever it was before. Well, this will be a negative. 2 and the 4 will make an 8. The square root 5s will times together to just make 5. Minus 7 times 1 is just minus 7. And minus 7 times that would be positive 28 root 5. And just to simplify a little bit, so 8 times 5 is 40, minus 7 plus 28 root 5. And now we can just collect our like terms. So 2 square root 5 plus 28 root 5 is 30 root 5. Minus, so 47 and, sorry, 40, negative 40 minus 7 is negative 47. Cool. And that's what that's the answer for question 3F. Cool. All right, I'll stop right there. Okay. So now I'm just going to go through question 4. 4A. And the question reads, simplify in brackets 3 plus root 2 squared. So 3 plus root 2 squared. Well, this is the same as saying 3 plus root 2 by 3 plus root 2. And now it's very kind of similar to the question above. So 3 and the 3 will make a 9. The 3 and the root 2 will make 3 root 2. This one will make plus 3 root 2. And the outer ones will be plus 2. We can combine like terms to make 11 plus 6 root 2, and that will be your answer. There might be some other teachers out there who suggest maybe doing something like this. This is like a perfect square, and so perfect squares, when you expand them, it would be this first term squared, so 9, plus these two terms times together doubled, so it would be 6 root 2, plus this last term squared plus 2. And you still get your same answer, 11 plus 6 root 2. It's just that some people like to learn it through expanding brackets, and some people want to learn it through um, expanding perfect squares. Either answer is fine, I would say. All right, cool. For B, so we're looking at 6 minus root 3 all squared. Similarly, there's a similar kind of pattern going on. 6 times 6 is 36. 6 times negative root 3 is negative 6 root 3 minus negative 6 root 3 plus 3. Collecting like terms, you get 12 root 3. Okay. For C, root 5 plus 1 squared. So this would be root 5 plus 1 by root 5 plus 1. So this will become root 5 times root 5 is 5 plus root 5 plus root 5 plus 1. So that would become 6 plus 2 root 5. Cool. For D, so what we're looking at here is root 8 minus 3 squared. Root 8 minus 3. The root 8 times the root 8 gives you positive 8 minus 3 root 8 minus another 3 root 8 plus 9. And then once again, collecting like terms, you get 8 plus 9 is 17 minus 6 root 8. For E, so what we're looking at is 4 plus 2 root 3 squared. 4 plus 2 root 3 by 4 plus 2 root 3. Okay. So the 4 and the 4, they was times to make it 16. These two are here will make plus 8 root 3 because the 4 and the 2 were times to make 8. Okay. Then this one and this one make 8 root 3. This one and this one would go 4 times 3. Yeah. So just to simplify a little bit more, 4 times 3 is 12. And then just collecting some like terms. 16 plus 12 it comes out to be 28 plus 16 root 3. Cool. For 4f, we're looking at 3 root 5 plus 1 squared. And this will become 3 root 5 plus 1 by 3 root 5 plus 1. Cool. So these two will times. So you get left with 9 times 5 plus, and then you multiply the other components. 45 plus 3 root 5 plus 3 root 5 plus 1. So 45 and the 1 makes 46 plus 6 root 5. Here, 4g. 7 minus 2 root 10 squared equals, so once again, 7 take 2 root 10 by 7 take 2 root 10. 7 times 7 is 49. 7 times 2 root 10 is minus 14 root 10 minus 14 root 10 minus, or sorry, that'll be a plus. 2 times 2 is 4. 4 times 10 is 40. And then just to collect like terms, you're looking at 89 minus 28 root 10. 4h, 5 root 6, take 4 squared equals 5 root 6 take 4, 5 root 6 take 4. And we're just going to expand some brackets now. So this will become 25 times 6 minus 20 root 6 minus 20 root 6 plus 16. Okay, so 25 times 6 is 150 minus 40 root 6 plus 16. And so that'll make 166 minus 40 root 6. Cool. So those are the 8 questions for part 4. So I'll go through the material in part 5 now. Okay. So question 5a is simplify again. 3 plus root 7 and 3 minus root 7. Cool. So these type of questions in question 5 are all written so that it's like a plus b and an a minus b. So if you have a look at the questions and you have the questions in front of you, all the questions kind of have the same pattern. The two sets of brackets are the same. It's just that one's a plus and one's a minus. Yeah. And the cool thing about expanding these type of brackets is that when you have two of the exact same things, but one's a plus and one's a minus, you don't need to do the long convoluted expanding like we've done in red before. What we can do is just multiply the first two parts together, and we can then just multiply the last two parts together. Yeah. And so if you had a plus b times a minus b, this would become a squared take b squared. Would be the answer to this expansion. Yeah. If you want to know why that's the case, feel free to just let me know through some of the comments, and I'll get to explaining why that is the case. Right. So for something like this, it will just be 3 times 3, which would make 9, and then minus root 7 times root 7, which is just 7. So the answer is just 2. Yeah. Cool. All right, 5b is root 2 plus 5 brackets with a root 2 take 5. Okay, cool. So once again, this times this, square root 2 times square root 2 is just 2. And because these two things are exactly the same, but one's a plus and one's a minus, we don't need to do all the different terms. We can just do the first terms and just the outer terms, or the last terms, sorry. All right, cool. So you got root 2 times root 2, which is 2, and then 5 times a negative 5 comes out to be negative 25. So that becomes negative 23. Cool. 5c. If you did want to just expand it out, 5c, if you did want to just expand it out traditionally, which is just the same normal method, you can. You'll get the correct answer. It'll just take you a little bit longer, which is normal. Yeah. All right. So 4 times 4 is 16, minus root 3 times root 3 is 3. 16 minus 3 is just 13. Cool. 5d, let's have a look. So you got 2 root 2 plus 1, and you got 2 root 2 take 1. Okay, so same thing. Because you have two sets of brackets that look identical, except that one's a plus and one's a minus, we can just multiply the first part and the last parts. So 2 square root 2 times 2 square root 2, that becomes 4 times 2. And then plus 1 times minus 1 is a minus 1. So this one will become 8 minus 1, which will come out to be 7. (5e), let's have a look. So 5e is 4 plus 3 root 8 and 4 minus 3 root 8. Cool. So 4 times 4 makes 16. 3 times 3 is 9, so that's a minus 9 times, and then the square root 8 times the square root 8 makes 8. So 16 So minus 72. And 16 minus 72, just making sure I don't make any mistakes. 54, I think. Sorry, 56. Sorry, my apologies. 56. Yeah, 56. Cool. 5f. And just to finish off, 9 root 3, take 5. And 9 root 3 plus 5. So once again, this times this, you'll make 81, because like 9 times 9 makes 81, times 3. And then you just do these ones, minus 25. 81 times 3 is 24/3, I think, or 243, yep, minus 25. And this will become 200 with a 1 there and an 8 there, I think. Yeah, cool. So those are the questions from 12A.2. I'll go through the material in 12A.3 in just one bit. All right, cool. So I'm going to go through the material from chapter 12A.3. This section here is all about this thing called rationalizing the denominator, or writing as an integer denominator. And I'll just kind of go through what they're talking about. So basically what they're trying to get you students to do for these particular type of questions is, if you have the answer or the number 1 over root 3 and you put it into your calculator, whoops, 1 over root 3, your calculator will give you the answer as root 3 over 3. It turns out that these two numbers are the same thing. It's just that sometimes it's more easier or more specific if we have the bottom number or the denominator to be a whole number or an integer. Yeah, and so what we just want students to know how to do is to convert from this into that. Yeah, how do we convert a square root denominator or a denominator with a square root into a denominator where there's no square roots at all? Okay, cool. So the general process on how you do it is you multiply the fraction 1 over root 3 by its conjugate. And conjugate is just a complicated way of saying you multiply it by the same square root number. Okay, so in this case it's square root 3. Okay, and whatever you put on the bottom, you put on the top. Yeah. The reason that we do this is because this is the same as multiplying by 1, because if you have square root 3 on the top and square root 3 on the bottom, it makes 1. Okay, now that's the kind of basic idea for these type of questions. There's a few kind of exceptions, but as we go through all the questions, 1A all the way to 1T, I'll just go through some of the exceptions one at a time. Okay, so let's have a look at this. So when you multiply fractions, it's just the numerators times together and the denominators times together. So 1 times root 3 becomes root 3, and root 3 times root 3 makes 3. Hence, that's how you get the answer from the calculator. Cool. All right. 1B. 1B follows a very similar kind of path. So your question is 3 over root 3, and we want to multiply it by root 3 over root 3. So the top will become 3 root 3, and the bottom will come just 3 by itself. Yeah. I'd encourage you to, once you do this kind of multiplication, just have a look, because in this particular case we can cancel out the 3's, so your answer will just be root 3 at the very end. Cool. All right, 1C, 9 over root 3, multiply that by root 3 over 3, so root 3 over root 3, so once again that becomes 9 root 3 over 3. And you can kind of like cross off these off a little bit, so you're left with 3 root 3 as your final answer. Cool. Okay, 1D. So you got 11 over 11 root 3. Once again, same kind of deal. You want to multiply that by root 3 over 3. So the top will become 11 root 3, and the bottom will just become root 3 times root 3. We'll just make it a 3 on the bottom. Cool. All right. And so these are the final answers that you would get in your textbook. 1E. So now we come to the very kind of first kind of different or exception to the rule. So for this one, the key thing is that we're multiplying by whatever the square root number is on the denominator. Okay, so in this case, because there's a square root 3 on the bottom, we multiply it by square root 3. We don't need to consider this number 3 in the multiplication step. So we just need to include this part here. Okay, cool. And so if we do this, the root 2 and the root 3, well, that will make root 6. Okay, and then 3 times, so root 3 times square root 3 will become 3 times 3, which will make root 6 over 9. Okay. 1f. 2 over root 2. So same kind of idea, but instead of multiplying it by root 3 on the top and bottom, we multiply it by root 2 on the top and bottom. Cool. So this will become 2 square root 2 over square root 2 times square root 2, that becomes 2. And this can cancel, so you're just left with root 2. G. So you got 6 over root 2. Multiply that by root 2 over root 2 again. So the top will be 6 root 2. And the bottom will be square root 2 times the square root 2 makes it 2 again. And this would partially cancel, so you're left with 3 root 2. Cool. H. 12 over root 2 times by root 2 over root 2 again. So the top one will become 12 root 2 over the bottom, which is 2. And once again, they will partially cancel out, so you're left with 6 root 2 as your final answer. Cool. Right, I'm just going to change the color. This screen seems a bit too bright for me. H, and then now we're up to I. So we got root 3 over root 2. Give me 1 second. So you got root 3 over root 2. Multiply that by square root 2 over square root 2. So the top will become square root 6 over square root 2 times square root 2 just becomes 2. Okay. And in this particular case, it doesn't look like we can simplify it further. J, 1 over 4 root 2. Now, once again, it's not necessary for you to consider this 4 when determining what to times it by. You just need to multiply it by the square root part. So just like that. And so the top will become 1 times square root 2, which is just square root 2. And the bottom will become 4 square root 2 times square root 2 would be 4 times 2 over 8. Cool. All right, what's next? K. 5 over root 5. Multiply that by root 5 over root 5. So the top will become 5 square root 5 over square root 5 times square root 5 is just 5. And very conveniently, they cancel again. So the answer is just square root 5. 1L. So you got 15 over root 5. And we times it by root 5 over root 5. So the top of the fraction, or the numerator, will become 15 root 5 over the bottom, which is the denominator. Square root 5 times square root 5 is just 5. And then once again, these can partially cancel off, so you're left with 3 root 5. 1m. So negative 3 over root 5. So it's the same kind of deal. You don't need to change anything just because it's a negative 3. You still just multiply or do the same kind of method. So this will become negative 3 root 5 over square root 5 times square root 5 is just 5. And in this case, once again, we just leave it how it is. Yeah, because 3 and 5 can't be simplified anymore together. All right. So we got 200 over root 5. Once again, times it by root 5 over root 5. So you would have 200 over 200 root 5 over 5. And then the 200 and the 5 can partially cancel out. So I think you're left with 40 root 5 as your final answer. Because the 5 and the 200 would make 40 left over. Question O, you got 1 over 3 root 5. Multiply that by, and same as before, you don't need to consider the 3 at all for this part. You just need to consider this square root 5. So we want to be multiplying this by root 5, root 5. So what you're left with is square root 5 over 3 square root 5 times square root 5 makes 15. Then we're left with P. So 7 over root 7. And it's the same kind of idea. Multiply that by root 7 over root 7. So that becomes 7 root 7 over square root 7 times square root 7 is just 7. These will cancel off. So we just left with is root 7. Hopefully students can kind of see the running pattern that's kind of going on with these particular kind of questions. All right, cool. Q, 21 over root 7. Well, we want to multiply that by root 7 again, or root 7 over root 7. So this will become 21 root 7 over 7. They will partially cancel out, so you're left with 3 root 7. R, 2 over root 11. Multiply that by root 11 over root 11. So the top will become 2 square root 11 over square root 11 times square root 11 is just 11. Cool. For S, now we're looking at 26 over root 13. Multiply that by root 13 over root 13 again. So this becomes 26 root 13 over 13. And they can partially cancel, so you're left with 2 square root 13. And lucky last, this one's a bit different. T. This one's kind of like the oddball of the group. Okay, so this one is square root 3 to the power of 3. Okay. Now before I start timesing it by the correct necessary parts, I first might just rewrite this in expanded form. So I might just write it out a little bit larger, or a little bit longer. Square root 3 times square root 3 times square root 3. So square root 3 times square root 3, that would be 3 root 3. Yep. So those square root 3s, when they get times together, become 3 square root 3. And then this question here, we might have actually done a question exactly the same as that. Nope, that's okay. We can just multiply this by root 3 over root 3. Okay. So that will become root 3 over 3 times 3. So root 3 over 9. And those are the questions from 12A.3, question 1. So yeah, I'll go through the material or the questions from part 2 right now. Okay. All right. So the questions from question 2, so 2A, is 1/3 plus root 2. And the question just reads, write with an integer denominator. So my guess is, if we put this on our calculator, 1/3 plus root 2, yep, the calculator will kind of rewrite it so that there's no square root number on the bottom. It'll try its best to write it so that the bottom number is a whole number. And so once again, for question 2, they're just asking you to do the same kind of thing. They're just trying to say, well, how do you convert 1/3 plus root 2 into 3 take root 2 over 7? It's like what they're asking you to do for this particular question. Similarly to before, you want to multiply this by something, but when there's like a plus or a minus there, it has to be its conjugate. And what we mean by its conjugate is that it has to be the same thing, 3 plus root 2, but whatever operation is on the square root number, it has to be the opposite. So in this case, it will be 3 minus root 2. And likewise, whatever is on the bottom is on the top. Okay. And so we're just going to expand this out. So the top one would become 1 brackets 3 minus root 2. And then the bottom would become 3 plus root 2, 3 minus root 2. Okay. And so now we just try to expand our brackets a little bit. And if we do it correctly, we won't have any square roots on the bottom. All right, so let's expand the top. So the 1 times a 3 will become 3. The 1 times a minus 2, negative root 2. Cool. And if you have a look on the bottom, what you notice is that there's two exactly the same things, but one's a plus and one's a minus. So we can expand this similarly to how we did, I think, question 4 from before. Question 5 from before. Yep. So this will become 3 times 3, which is 9. And then minus root 2 times root 2 will become 2. And so what we're left with is 3 minus root 2 over 7, which is the same kind of answer we get from the calculator. So that's good. So that's the kind of methodology that you want to do. The key thing here is that you're multiplying by its conjugate. And what we mean by conjugate is that it's the same kind of denominator with the square root. It's just that whatever the square root symbol is, if it's a plus or a minus, you write it as the other one. Okay. So I'll do part B as well, just to see the example. Okay. So what you have here is, I'll zoom out just a little bit. Actually, I'll do it on the side so it's all in one frame. So 2b. So this one is 2 over 3 minus root 2. And we want to multiply it by its conjugate. So 3 plus root 2 over 3 plus root 2. And then we just try to expand this a little bit. So we have 2 brackets 3 plus root 2 over 3 take root 2 by 3 plus root 2. And then we go through the arduous kind of process of expanding everything. So 2 times 3 is 6, plus 2 root 2, all over 3 times 3 is 9, minus 2. So what you're left with is 6 plus 2 root 2 over 7. All right, let's keep going. Question 2c. Question 2c. 1 over 2 plus root 5. Multiply that by, I might just rewrite this. 1 over 2 plus root 5. Multiply that by 2 minus root 5 over 2 minus root 5. Cool. And then we just want to expand this out. So on the top, it'll be 1 time all that, but that's going to be okay, it'll just be the same. And then this will become 2 plus root 5 by 2 minus root 5. And just like before, 2 minus root 5 over, expand it using the difference of squares. So it'll be 2 times 2 is 4, minus 5. So we're left with is 2 minus root 5 over minus 1. And if you want to be really complicated, you can rewrite this as negative 2 plus root 5. The minus 1 on the bottom will kind of flip all the signs or flip all the terms into their opposite signs on the numerator. Cool. And so just to confirm, we're just going to check this on my calculator just to see if I've done this correctly. 2 plus root 5. Yep, cool, wonderful. All right, let's have a look at question 2D. So you got root 2 over 2 minus root 2. So we want to multiply by its conjugate again, which is 2 plus root 2, 2 plus root 2. Root 2 brackets 2 plus root 2. And then this will become 2 minus root 2, 2 plus root 2. I understand I'm saying like lots of 2's. This question just has a lot of 2's in it. So just expanding the top, you would have 2 square root 2 plus, and square root 2 times square root 2 will just make it 2. Cool. And for the bottom, once again, it'll be 4 minus 2. So you're left with 2 square root 2 plus 2 all over 4 minus 2, which is 2. And now we can just cancel off a little bit of things. So you can factorize the 2's out. Oops. Sorry. Just give me 1 second, guys. Not too sure why I'm here, so I'll just quickly this out. But what we'll do is just collect factor, so 4 minus 2 is just 2. We're then just going to factorize out. And we can cancel off these guys. And so what you're left with is just root 2 plus 1. So yeah, this is a bit of a long process. It's a bit kind of tiring and impressive. But this is just one that is the process of rationalizing the denominator. Alright, cool. So let's go on to the next one, which is 2e. Okay. So next part is 2e. 10 over root 6, take 1. So similarly, we're going to multiply by its conjugate. Root 6 plus 1, root 6 plus 1. And so after we have that, the top will become 10 in brackets, square root 6 plus 1, all over, in this case, it will be square root 6, take 1, square root 6 plus 1. When you expand brackets, it will become 10 square root 6 plus 10 over square root 6 times square root 6 will become 6 minus 1. Okay. So e, you're looking at 10 over square root 6 minus 1, multiply that by root 6 minus 1, root 6, plus 1, my apologies. So you got 10 brackets root 6 plus 1. Root 6 times root 6 is 6. 1 times 1 is 1, so it's a minus 1. And so what we have here is 10 root 6 plus 10 all over 5. And we can factorize some of this out. cancel off the 5s, and so what you're left with is 2 root 6 plus 2. Good answer. For 2f, you're looking at root 3 over root 7 plus 2. Multiply that by root 7 take 2 over root 7 take 2. So this will become root 3 times by root 7 take 2 all over, now root 7 times root 7 becomes 7. Positive 2 times a minus 2 becomes a minus 4. So this will become square root 3 times square root 7 makes square root 21 minus 2 root 3 all over 3. Alright, after f we got g, halfway there. So you got 1 plus root 2 over 1 take root 2. And we're just going to apply the same kind of method, just a number that's on the bottom, but the conjugate of it, so 1 plus root 2. And we're just going to expand this out. So 1 plus root 2, plus root 2, all over 1 times 1 is 1, minus root 2 times root 2 is 2. And so what you're left with is, let's expand the top as well. So 1 times 1 is 1, plus root 2, plus root 2, plus 2, all over minus 1. Cool. And so just collecting some like terms, the 1 and the 2 makes 3, plus 2 root 2, all over minus 1. And the minus 1 can change all the operations, all the polarity on top, minus 2 root 2. Cool. Alright, what's next? 2h. Root 3 over 4 take root 3, multiply that by 4 plus root 3 over 4 plus root 3. So this becomes 4 root 3 plus 3 all over 16 take 3. So 4 root 3 plus 3 all over 13. Alright, 2i. So we have minus 2 root 2 all over 1 minus root 2. Multiplied by its conjugate, 1 plus root 2, 1 plus root 2. So if you expand the top, it will become minus 2 root 2 minus 2 root 2, sorry, minus 4 all over 1 take 2. So this will become minus 2 root 2 take 4 all over minus 1. And then the minus 1 on the bottom by itself changes all the signs on the top. Cool. Alright, 2j. So you got 1 plus root 5 over 2 take root 5. Multiplied by its conjugate, 2 plus root 5 over 2 plus root 5. So this one would expand into 2 plus root 5 plus 2 root 5 plus 5 all over 4 minus 5. The 2 and the 5 will make 7 plus 3 root 5 all over minus 1. And then this minus 1 can change the operations or change the signs on the values of the numerator. All right. And 2 left. 2k, which is root 3 plus 2 all over root 3 take 1. Multiply that by its conjugate, so root 3 plus 1, root 3 plus 1. So this will become root 3 times root 3 is 3, plus root 3 plus 2 root 3 plus 2. All over root 3 times root 3 is 3 minus 1. So now we just collect some like terms. 3 and the 2 make a 5. Root 3 plus 2 root 3 becomes 3 root 3. All over 2. Lucky lost. Root 10 take 7 over root 10 plus 4. Root 10 minus 4 over root 10 minus 4. So just expanding the top, this will become 10 minus 7 root 10 minus 4 root 10 plus 28. All over 10 minus 16. 10 plus the 28 makes 38 minus 11 root 10 all over 10 minus, so that'll be 6. And I'm pretty sure you can't simplify this anymore, mainly because 11 is a prime number. Yeah, because 11 is a prime number. Okay, cool. So there's all the material and all the questions from chapter 12, A. So that's 8.1, 8.2, 8.3. Okay, cool. All right, good luck, everyone. I'll leave it at that.